we need to balance the forces. So in that case, we use the Lamis theorem. So we will apply some problems based on Lamis theorem. Suppose we are taking some example. We have this, we have something like this. An object is hanging, and okay. Suppose this kind of system. We have two strings connected. One is at 53-degree angle and second is at 37-degree angle from the ceiling. And these are two strings, and there is a mass m. This mass is suppose 5 kg, and the mass is acting here. So weight will be mg here. So we have to find tension in the two strings. So what we are provided with? We are provided with an object mg which is tied with two strings. Suppose tensions are T1 and T2. We need to find these two tensions. So how do we find the tension in the two strings? So we will use the Lamis theorem. If this system is hanging like this, so this is stationary and all forces are balanced on this system. So if all forces are balanced on this system, it means the forces are in equilibrium. The object at rest, object is at rest. So it is in equilibrium. It is in equilibrium, and if it is in equilibrium, then it should satisfy the Lamis theorem. So applying Lamis theorem. So how do you apply? We need to know the angles first. So these are the forces. One force is T2, another force is T1. The tension from the strings. These two forces, the tension here, and a weight here. So these three, one from one side, and this object is pulling, this thread is pulling. From other side, this thread is pulling, and from third side, a weight is pulling. So these are the three forces. And what will be the angles? So angle, if we say this is 53, so this will be 37. So this side angle will be how much? This will be, we say this angle, and this will be how much? This is 53, this is 53. So 90 plus 53. So this will be 143. This side angle is 143, and this side will be again. This is 37, so this is 37 up to here. So 90 plus 37. So this whole angle will be 127 degree. So left hand side is 143 degree, right hand side is 127 degree, and upper side, this one will be how much? 37 and 53. So this will be 90. Because these three are forming right angle triangle. This is right angle actually. Because 53, 37 plus 90 is total 180. So these are the three angles. Now we will write the mg is first force, mg by the angle in front of it, 90. So sine 90. Then T1 and the angle in front of T1. The angle in front of T1 is 127. So sine 127 degree. And then T2, we will write sine 143 degree. So this we can write. And if we solve it further, the mg is 5 kg. So 5 kg into 10 meter per second square. So that will be the acceleration mg. And sine 90 is 1. T1. Sine 127. So how much will be sine 127? Sine 127 can be written as sine 37 only. So sine 53, because it is 180 minus 53. So we can write sine 53. And this one can be written as T2 by sine 37. Sine 143 can be written as sine 180 minus, so I am writing is, this is 180 minus 53. That's why I have written finally 53. And this is what? 180 minus 43. Sorry, 180 minus 37. So that is equal to 143, and this was equal to 127. So from there we have written. Now if you can solve it further, it will be 50 Newton and T1. So sine 53. Sine 53 is how much? 4 by 5. And sine 37 is 3 by 5. So now you can find T1. T1 will be equal to 4 by 5 into 50, and T2 will be equal to 3 by 5 into 50. So this is 40 Newton and this is 30 Newton. So in this way we can solve the questions, and we can find the tension in the two objects. Two threads, the tension we are going to have 40 Newton and 30 Newton. बोलिए कुछ डाउट है इसमें?